Hi class, for these type of examples we're going to be graphing lines, but we're also going to be looking at specific coordinate points which happen to be, in this case, the intercepts. So we're going to be looking at those values, and on the first problem, problem A, they want us to find the x and the y intercept of the problems. So you're given a graph, so in this case we're looking at these two coordinate points. So the coordinate point there and this coordinate point. So let me write my solution here. In this case, the y-intercept is at, and the y-intercept is 0, -6, and then the x-intercept happens to be at 2, 0. So 2, 0. We're going to be using a different way of graphing, which it is still using coordinate points, but it's going to use less coordinate points, and it'll be a little bit easier to graph. Some of the problems that we're going to be given, for example, this is the equation. As you're plugging in coordinate points near 0, they may end up with messy fractions. So in that case, it may just be easier to do the x and the y intercept. So that's actually it for problem A. Let's take a look at problem B. Now problem B, they want us to find the intercepts, but this one is a horizontal line, so you're only gonna have one value. So in this case, only the y-intercept, which happens to be at 0, 2. So horizontal lines, well, in this case, this particular horizontal line, it's never going to go into the x-axis, so it's not gonna have one. And let me just highlight here what I'm pointing. It's only gonna have a y-intercept, no x-intercept, and if they're asking for both, I'll just mention that no x-intercept. And the software may be asking for like an empty set. It all depends if they show up on the homework or quizzes questions. So that's actually it for the first two. It's really easy to identify these problems. Sorry you guys, I'm using a different software, which is Word, but it makes it easier to graph the lines, but it makes it a little bit harder to write on it. Okay, let's take a look at another problem. And here they want us to graph by finding the x and the y intercept. So let me start with the y intercept. So your y intercept is going to start, or it's going to be at the coordinate point where the x's are equal to 0. So we're looking at technically this point here. When x is 0, that's your y intercept, and same thing here. When x is 0, that's going to be your y-intercept. So in order to solve it algebraically, you're simply going to say let x equal to 0 and plug it in. So you're going to end up with 3x plus y is equal to 7. We're plugging in 0, so we're going to end up with 3 times 0 plus y is equal to 7, or y is equal to 7. So 0, 7 would be the y-intercept. And let me just plot that point. 0, 7 is here. The x-intercept, so in this case, so the x-intercept is going to occur as we let, in this case, y equal to 0. As we look at the y is equal to 0 here, that's going to give us a proper point. And let me show you. So here, your y coordinate point, it's 0. That's why you end up with 2, 0. So for this problem, we're just going to let y is equal to 0 and then plug it in. So you're looking at 3x plus y is equal to 7. Plugging in 0 will give us you're plugging it in into the y's. So you're plugging it in into the y's. So in this case, we're going to end up with 3x plus 0 is equal to 7, or 3x is equal to 7. And then if we divide by 3, we're gonna end up with x is equal to 7/3, which is gonna be 2 and 1/3, or 2.33333. So 2.33, repeat it. And this is why I mentioned that it may be easier to just use the intercepts, because some of these are going to provide messy coordinate points. So in this case, we're looking at 2 and a little bit of cash, which is here. Oh, that's not really the point, but I'm just going to place it here. It's the closest. And let me write the x-intercept. And our x-intercept happens to be 7/3, comma 0. I'm just going to leave it like that, since it may be easier to identify it as 7/3 or 2 1/3. I guess I can write it like that too, which is actually exactly the same as 2 1/3, comma 0, or approximately 2.33, comma 0. One of those is just sufficient. And let me try to use the software to graph the line. So in this case, I decided to use Word for these because the coordinate points are going to be farther apart, so the lines are not going to look straight at all. Okay, so give me just a second. And obviously we're still using this to scale, but that happens to be our line crossing through those two coordinate points. Let me just make it a little bit thicker. And that's our line. Let me go back to the drawing. The coordinate points that we found were 0, 7, which is here, and then 2 1/3, which is technically there. On your end, you're just doing a basic sketch. I'm trying to display the whole problem, but it's not. There we go. It's not letting me show it. So that's actually it for problem C. Let's move to problem D, which is a very similar problem. And then on this one, well, let's start with the y-intercept. So you're gonna let x equal to 0, and then we have 2x plus 3y is equal to 12. And this will give us 2 times 0 plus 3y is equal to 12, or 3y is equal to 12, and then we'll divide by 3, so y is equal to 4. And then let me just rewrite it. The y-intercept is at 0, 4. So that's going to give us this coordinate point. And then the x-intercept we're gonna simply let the y equal to 0, and we have 2x plus 3y is equal to 12. And then now we're gonna plug it in for the y's. So 2x plus 3 times 0 is equal to 12, or 2x is equal to 12. If we divide by 2, you're gonna end up with x is equal to 6. So the x-intercept, it's gonna be 6, 0. which is going to be this coordinate point here. Let me draw the line. And give me just a second, let me make it a little bit thicker. Okay, there you can see the actual line. The coordinate points that we found, it was 0, 4, and then 6. So in this case, we ended up with nice values to evaluate. I'll just display both problems here. And this idea of graphing with the intercepts, it's a little bit easier. Some problems, as I mentioned before, plugging in values near the origin may result on very messy fractions, so it may be more appropriate for some problems to just use the intercepts. That's actually it for these 4 problems.